Hello everyone. In previous lecture we have seen the first activity related with magnetic field, and that is nothing but the magnetic field due to current through a straight conductor. And in that activity we have seen there are the two main factors which affect the strength of the magnetic field produced. That is nothing but the magnitude of electric current, and another is the distance of a point from the conductor, or we can say the perpendicular distance of a point from the conductor. Means as we increase the electric current, or as we increase the magnitude of electric current, then the strength of magnetic field also get increased. And as the electric current flowing through a conductor, we know that whenever the electric current flowing through a conductor, then it produces magnetic field. So if we increase the electric current, then magnetic field also get increased. And as the magnetic field, as the distance of an object or distance of a point from the conductor get increased, then the magnetic field get decreased. As we have seen the circular loops or the circular concentric circles around a straight current carrying conductor when electric current flowing through it. So as we move away from the straight current carrying conductor, then the concentric circle becomes larger and larger, and it indicates that the magnetic field goes on decreases as we move away from the straight current carrying conductor, and as we move towards the straight current carrying conductor, then the magnetic field get increased. So there are the two main factors which affect the magnetic field, that is the magnitude of electric current, and another is the distance, or we can say the perpendicular distance of a point from the straight current carrying conductor. Now today we will see the next activity, that is activity 2, magnetic field due to current through a circular loop or a circular coil. Now for this activity, what we require a cardboard having 2 holes, then a coil having large number of turns. So this is a coil, or we can say this is a loop having large number of turns of wires. So this coil or loop is made up of large number of turns of a copper wire or any kind of wire. So this coil is made up of large number of turns of wire, and then it becomes a coil. Then we have a battery, plug, key, rheostat and ammeter. So first we have to take a coil having large number of turns and insert it through a cardboard having 2 holes. Then now connect the 2 ends of a coil to the battery, key, rheostat and ammeter. Now sprinkle some iron dust or iron filling on the cardboard uniformly or evenly, and switch on the key, or we can say the key is closed, so that the current flowing through the coil. Now whenever the current flowing through the coil, gently tap the cardboard so that the these iron fillings or the iron dust, after some time we can see the concentric circles of iron dust or iron fillings are formed around the 2 ends of the coil. So at the 2 ends of the coil, the concentric circles of the iron dust or the iron filling are formed around it. So it indicates that, or it represents that, the magnetic field is produced around the coil. Now as we know that as we increase the current, then magnetic field get increased. Now this coil is made up of large number of turns, and the direction of the wire is same. So the 1 turn of the wire produces magnetic field. So the n number of turns produces how much magnetic field? The n number of turns produces n times of magnetic field. As the 1 turn produces magnetic field, so if the coil is made up of n number of turns, then that n number of wires also produces magnetic field. So how much magnetic field is produced by the coil? The magnetic field produced by the coil is n times. Why n times? Because the coil is made up of n number of turns, and as the electric current increases, the magnetic field also get increases. For example, suppose 5 ampere current flowing through the 1 turn of the wire, then this coil is made up of n number of turns. So in each turn the 5 ampere current produces, or the 5 ampere current passes through each turn of the wire, and therefore each turn of the wire produces magnetic field. So it produces magnetic field. So if there are n number of turns, then n times the magnetic field is produced. So what is the conclusion of this activity? So in first activity, we conclude that as we increase the magnitude of electric current, then magnetic field get increased, and the magnetic field get decreased if we increase the distance of a point from the current carrying conductor. Now in this case, the coil consists of large number of turns, or the coil consists of n number of turns. So this n number of turns produces n times the magnetic field. Means if we increase the number of turns, then magnetic field also get increased, keeping the electric current constant. Now in this case, the magnitude of electric current remains constant. For example, 5 ampere. So 5 ampere current flowing through the coil. It means that the 5 ampere current flowing through each turn of the coil. And what is the direction of the wire? Direction of the wire also same. So the direction of the wire inside the coil are same. So each turn of the wire produces magnetic field, because the 5 ampere current flowing through each turn of the wire, 5 ampere current flowing through each turn of the wire, and therefore each turn of the wire produces magnetic field. And if this coil consists of, suppose this coil consists of 100 turns. So if this coil consists of 100 turns, then how much magnetic field produced? The magnetic field produced 100 times. If this coil consists of 1000 turns, then how much magnetic field produced by the coil? The magnetic field produced by the coil is 1000 times. So as we increase the number of turns, then magnetic field also get increased, and this is nothing but the conclusion of this activity. So what is the conclusion? If number of turns increases, or if number of turns in the coil increases, then magnetic field also increases. So this is the conclusion of this activity. That is, if number of turns in the coil increases, then magnetic field also increases, because this coil consists of number of turns, and the current flowing through the coil is flowing through the each turn of the coil remains same. So, and the direction of the wire or the direction of the current flowing through the coil is also same. Therefore, the coil produces n times the magnetic field. So we have the three factors which affects the strength of the magnetic field. So factors affects strength of magnetic field. So the first factor, that is nothing but the magnitude of electric current. Second, perpendicular distance of point from the conductor. And third, number of turns of wire. So these are the three main factors which affects the strength of magnetic field. Means the strength of magnetic field may get increased or may get decreased because of these three factors. First is the magnitude of electric current, and how the magnitude of electric current affects. If we increase the electric current, then the magnetic field get increased. If we decrease the electric current, then the magnetic field get decreased. Then second is perpendicular distance of point from the conductor. If we move away from the conductor, then the magnetic field get decreased, and if we move towards the conductor, then the magnetic field get increased. So it is inverse, distance is inversely proportional. And the third is number of turns. If we increase the number of turns, then the magnetic field get increased, and if we decrease the number of turns of wire, then the magnetic field get decreased. So from this second activity, what we conclude? The number of turns of wire. If we increase the number of turns of wire, then the magnetic field get increased. So from first activity, we get the two factors which affect the strength of magnetic field, and from second activity, we get the third factor which affects the strength of magnetic field. So just we see how the activity is going on. That is what we require. We require a cardboard having two holes and a coil having large number of turns. Then we require a battery, plug key, rheostat and ammeter. So the large number of a coil having large number of turns, insert the coil of large number of turns through the two holes of a cardboard, and the two ends of the coil is connected in series with battery, plug key, rheostat and ammeter. Then sprinkle some iron dust on the cardboard evenly and switch on the key. So as soon as the key is on, the current flowing through the wire or current flowing through the coil and the magnetic field is produced. And how we know the magnetic field is produced? It is shown by the concentric circles of the iron dust formed around the two poles or around the two ends of the coil. So at the two ends of the coil, the concentric circles of the iron dust are formed, and it indicates that the magnetic field is produced. And therefore, how much magnetic field is produced? As the number of turns are there. If there are large number of turns, then the magnetic field produced will be more. If there are less number of turns, the magnetic field produced will be less. So the magnetic field produced depend upon the number of turns of wire inside the coil. So the conclusion of the activity is that if number of turns in the coil increases, then the magnetic field also increases. So hope you understand this activity very well. The next topic is magnetic field due to current through solenoid. Now first of all, what do you mean by solenoid? Now in previous activity, we have seen a circular magnetic field due to current through a circular loop or a circular coil. So that circular coil is made up of large number of turns. So this coil of many number of turns of insulated copper wire arranged in the shape of cylinder, closely arranged in the shape of cylinder, that is called as solenoid. So in previous activity, we have seen a coil having large number of turns of wire. So that is also called as solenoid. So solenoid is nothing but a coil of many circular turns of insulated copper wire arranged closely in the shape of cylinder, that is called as solenoid. So what is solenoid? So solenoid means coil of many circular turns of insulated copper wire arranged closely in the shape of cylinder is called as solenoid. So this is called as solenoid. So solenoid means coil having large number of turns of insulated copper wire which is in the shape of cylinder, and this wire is connected with battery and plug key. Means whenever the electric current flowing through this copper wire, the magnetic field is produced, and the magnetic field produced by solenoid is similar to the magnetic field produced by a bar magnet. So the bar magnet, as the bar magnet produces magnetic field, so the solenoid also produces the same magnetic field when current flowing through the solenoid, and therefore it is the magnetic field due to current through a solenoid. So how the magnetic field lines produce when the current flowing through the solenoid? So the pattern of magnetic field lines around current carrying solenoid. As already we have seen, the magnetic field produced by solenoid is same, or it is similar to the magnetic field produced by the bar magnet, and therefore the pattern of magnetic field line is also same with the bar magnet. So the magnetic field lines produced by the bar magnet is similar to the pattern of magnetic field lines around the current carrying solenoid. So here also this is the solenoid, and whenever the current flowing through the solenoid, then it produces magnetic field. And how we know the magnetic field is produced? It is represented by the magnetic field lines, and therefore these are the pattern of magnetic field lines. So here the magnetic field lines are emerges from north to south, and it merges at south to north. So it originates from north to south and ends at south to north. So this is the pattern of the magnetic field lines. Now here you can say that how the magnetic field lines inside the solenoid. So inside the solenoid we see that the magnetic field lines are parallel to each other. So what is the pattern of magnetic field line inside the solenoid? This is the pattern of magnetic field lines around the solenoid. So it is just similar to the bar magnet. In bar magnet also we are saying, suppose this is north and south, or we can say this is north and south. So the field lines emerges from north and merges at south outside the magnet, and from south to north inside the magnet. So here also merges from north to south outside and south to north inside the magnet. So inside the magnet, the magnetic field lines are parallel to each other. So how the pattern of the magnetic field line inside the solenoid? Inside the solenoid, the magnetic field lines are parallel to each other. And as the magnetic field lines are parallel to each other, so the magnetic field inside the solenoid at every point remains constant or remains uniform. So how the magnetic field inside the solenoid? Inside the solenoid, the magnetic field is constant. So magnetic field is constant inside the solenoid. This is the important point. How the magnetic field inside the solenoid? The magnetic field inside the solenoid is constant. Now why the magnetic field is constant inside the solenoid? Because the magnetic field inside the solenoid are parallel to each other, and as the magnetic field lines inside the solenoid are parallel to each other, therefore the magnetic field is constant. So what is the reason? The magnetic field lines are, so the magnetic field lines are parallel inside the solenoid. So there may be a question asked, what is how the magnetic field lines inside the solenoid, or the pattern of magnetic field line inside the solenoid? The pattern of magnetic field line inside the solenoid are parallel to each other, but the pattern of magnetic field lines around the solenoid is similar to the bar magnet. That is, it is emerges from north and merges at south. But what about the inside solenoid? Inside the solenoid, the magnetic field lines are parallel to each other, and as they are parallel to each other, therefore magnetic field is constant at every point inside the solenoid. And as the magnetic field is constant, therefore the solenoid produces a large amount of magnetic field, or it produces strong, we can say strong magnetic field. So the magnetic field inside the solenoid is constant, and therefore solenoid produces strong magnetic field, and this strong magnetic field inside the solenoid is used to magnetize the material, magnetize the magnetic material, and therefore it is used to produce electromagnet. So what is the application, main application of the solenoid? It is used to produce the electromagnet. That is, now what do you mean by electromagnet? Electromagnet means whenever a magnetic material like soft iron is placed inside the current carrying solenoid, then it magnetizes the material, and it is called as electromagnet. So electromagnet means if any magnetic material like soft iron is placed inside the current carrying solenoid, then it magnetizes the material, and as it magnetizes the material, that material is called as electromagnet. So this solenoid is used to produce electromagnet. Now, so hope you understand what you mean by the solenoid. What is solenoid? Solenoid is nothing but the coil of many circular turns of insulated copper wire arranged closely in the shape of cylinder is called as solenoid. Now, if we are not applying battery or electric current, then it is only the it is only the coil having large number of turns. But when we called it as a solenoid, when the current flowing through it. So it is necessary, if the battery is not there, then the solenoid does not produce magnetic field. So it is necessary that the solenoid should be current carrying. So whenever the solenoid is current carrying, then and then it produces the magnetic field. And how it produces the magnetic field? The magnetic field should be constant inside the solenoid. Why it is constant? Because the magnetic field line inside the solenoid are parallel to each other, and as they are parallel to each other, therefore the magnetic field inside the solenoid is constant, and therefore the solenoid produces strong magnetic field inside it, and this strong magnetic field inside the solenoid is used to produce the electromagnet. And how it produces electromagnet? When a magnetic material like soft iron is placed inside the solenoid, then it magnetizes the material, and that material is called as electromagnet. So this is about the solenoid and the current through solenoid. So hope you understand what you mean by solenoid and how the magnetic field produced by the solenoid. Thank you.